Before we start correcting this week's assignments, let's first look at some of the problems you encountered that were sent into the WeChat group. So the first one is from Brooks, and his problem was that I never received his email. The reason was because there was no extension on the file name, so he named the file, but there wasn't an extension like .py after it. Right now we're looking at the properties of the file, and you can tell that there is no file extension. In fact, when you're saving the Python file, the default is .py, so when you're saving it, you don't need to change anything, and it should have a file extension called .py after it. Next, let's look at Brian's problem. In the email, he said that he can open the Python file successfully, but it closes after a flash, and he's asking how we should fix that. So I can successfully run the file, which means that he saved it properly. So the reason why this problem is happening is probably because he's opening it in a different way. The way that we usually open it is directly in the IDLE, like where you're writing the code. You can run it directly from there and then it will work properly. If you run it in a different way, for example, directly using Windows, then it uses the interpreter and then it runs the code like that. But after it runs the code, it immediately closes the file. That's why it closes very fast. So if you open it using Windows, it runs it and then it returns immediately to Windows afterwards. That's why the file closes. Here are all of the files in the Windows File Explorer. If we open it using the open with and then Python, we can see that it closes very fast. When you run it like that, it also gets a result, but you don't see it. So let me show you the correct way to run these Python files. Normally, we would open them like this. You search for IDLE in the taskbar. And then click File and Open File. And then you just find the Python file you're trying to open, and then it opens it. And then you have the file open and you can see your code. So this is the developing environment where you fix your code and stuff. You can run it from here and then you see the results. If you run it this way, it won't go back to Windows or your computer. So that's how we usually open Python files. Next, let's look at some of the problems that Summer had. So when she was sending the email, she wasn't able to attach the Python file into the email. It looks like you're doing it in Outlook, and Outlook has a pretty high safety standard. Because Python files can sometimes be a threat, the Outlook email system doesn't allow it to be sent with the email. Outlook doesn't let you send Python files in emails because they can be dangerous towards the receiver's software, hardware, and other data. To be able to send Python files in the email, since you're using Gmail, then you can just directly use the web Gmail and then it should be able to send Python files. Some other ways to do it include using a WinRAR compression tool to compress the Python file into a smaller file. After you compress the file extension is no longer .py and it turns into .rar. When it's .rar, the Outlook email allows you to send it freely. But if you didn't previously have this WinRAR installed, then you don't need to install it, because by installing something new, it will interfere with your computer's running. By installing anything onto your computer, it interferes with the booting and the memory. So if you don't previously have it installed, then you can directly use the web version of the email to send Python files. So you can use any of these two methods to send Python files. Now I'm checking to see who turned in the homework. Here's all the homework that have been successfully sent and that I received. Let's start with the first one, which is Ellie Wang's. So we have a folder for hers because the name is not right. For the formatting, you don't need to put brackets between the RC2203. So the code looks pretty good, and let's try running it. So it printed 97 and 100. The 97 is the ASCII number for the symbol lowercase a. So we printed x, which is the ASCII of a, and y, which is x plus 3, which is 100. And then it printed a and d, which are the characters for the ASCII codes 97 and 100. At the bottom, there's some code for debugging. Let's look at this part of the code and run it. So I can run it from up here. And then it gives us these numbers. The first one is the ASCII numbers for the character A. So the character A has an ASCII code of 97, and then they found the binary of 97 and gave it to the variable D, which they also printed in the last line. In the last line, they turned the binary back into an integer, which is 97. And then in the first print, they printed the binary, which is the first number that appears. The other two numbers are the decimal and octal numbers for the letter A. Next, let's look at Henry's. In the first line, x is 97. The second line, y is x plus 3, which is 100. And then he printed x and y. Let's see and try running it. And then he printed the characters of x and y, which is a and d. After, there is a variable C, which is the ASCII of A, which is 97, and D, which is the binary of C. And then he also printed the octal and decimal numbers for 97. In the last line, the octal and decimal numbers were turned back into integer, which is 97 again. And then let's look at the second code of Henry's. So he gave the variable x the value of the ASCII code of the capital letter A, and then he printed x. Let's try running this one. So it prints 65 for the first one, and then the second one is the character of the code point 911, which is the omega symbol. Next time for Harry, you don't need to put your two codes into separate documents. You can put them into the same file for the same meeting. For Ellie's, we already looked at hers at the top. We converted the RAR file into a Python file. And that was her other Python file. So in this file, it is the result after running the Python file, and this isn't what we want. We want the Python file with the code in it. We can tell that this is a result after the running because this is in shell. So you define two variables and then you printed it, and then you can immediately see the printed result, which is 97 and 100. So this is what you use when you're testing out new code, but don't need to send it to me. And then the file after that is a compressed file, which we also don't need to look at. We just need to look at the Python file. And then Brooks sent me two. The first one didn't have a .py file extension, and the second one does, which is pretty good. In the code, they gave the variable x the string hello world with all capitals, and then the variable character name with the string Brooks. And then they printed x.lower, which turns all of the letters in the variable into lower cases, and then a comma afterwards. So it will print hello world in all lower cases and a comma with a space after it. So let's try running it. So it prints hello world in all lower cases and a comma. The comma should have a space behind it too, which is also there. After that, it skips a line because between each print statement, it always skips a line. So the next print prints my name is with a space afterwards, and then character name variable, which contains Brooks, and then a period afterwards. So it puts all of these three things together and prints them. And let's look at the next code. So this is printing x, which is the ASCII of lowercase a, which should be 97, and printing y, which is the character of ASCII code 911, which is omega. And then let's run this code. Yes, so it prints 97 and omega. Next, let's look at Brian's. His code is correct. He first prints the character of code point 911, which is omega, and then prints the ASCII code of lowercase a, which is 97. So when we run it, it prints omega and 97. The next one is also Brian's. I don't know why there are two of them, but they're the same thing, so they're both right. Next is Daniel's. So let's run it first. In the first few lines, he finds the ASCII of capital letter A, which is 65, and then he finds the character of 65, which is capital letter A, and gives it to the variable D, which wasn't ever used. And then in the third line, he prints C, which is 65. That's the first one we see right there. And then he prints the binary of 911, which is the second number that's printed. And then the next few lines are all numbers that correspond to 65, but in different formats. The third number is 65, but in octal, and then the hex one is 65 in decimal, and the last one is 65 in integer, which is also 65. So there are two for Daniel's. The difference is that one of them has a print C and the other one doesn't. So the print C is something that happens in the middle, and you don't need to send two Python files. If you don't want it, you can just turn it into a comment by adding a hashtag in front of it. So I can see that you wrote it, but when I run it, it's not there. So that's for Daniel's code. Next, let's look at Dylan's. So he first put x equals ORed A, so he gave the ASCII code of capital letter A to x, and then he printed x. And then for C, it is the character of the integer 911. For here, you don't technically have to put integer for 911 because it is already an integer. This isn't wrong, but you just don't need to do it anyways. And then he prints C. So it gives us x, which is 65. That's the code point for capital letter A. And then C, which is omega, which is the character for code point 911. That's very good. So Felix handed in the first assignment, which is print hello world. And next time in meeting number 3, you can hand in the second one and the third one together if you want. For the first times, it's correct. Next is Gary's. I rewrote his code because in the third line there isn't technically a mistake, but it is better if you write it like the brackets around 911 but without brackets around CHR. So for print it has a bracket behind it, and for char has a bracket behind it, but you don't need brackets around the char. It might not give an error, but it's better to write it conventionally. So when we run this version, it prints omega for the second print. And so we know that this one works. And then let's see if Gary's original one also works. It also works. So we know that this doesn't give us an error, but it's still best to write it the other way. Python has this function of letting some different styles of writing. So Grace found the character of code point 911 and printed it, and it prints omega, and this part is right. Next we have Henry's again, but these are different file types, and we already looked at the Python files at the beginning of the video, so these are good and we can skip them. Next is Jeremy's. This is for the code for the first class again, so it prints hello world. Hello world successfully. This one is good. And then Matthews, he printed the ASCII code for capital letter A, which is 65, and the character for code point 911, which is omega, which is correct. And then for Mitchell's, he printed the symbol and the ASCII code on the same line. So the 65 and the omega are printed together, which also works. And then for Richards, he first printed the ASCII code for lowercase a, which is 97, and then he printed the character for code point 911. So when we run it, it prints 97 and omega. For Adrian's, his name starts with an A, but why is it at the bottom of the list? That's because instead of putting RC2203, he put RC2204. The 3 is because our class started in March. So the right one should be RC2203, and then your name would be at the top next time. Also, you don't need to put the number 2 meeting assignment afterwards. So your code says print the ASCII code of A, lowercase a, and 911, which is 97 and omega. Yes, that's right. Next, let's look at Joey's. Joey gave a variable C, which contains the ASCII code of capital letter A, and a variable D, which contains the binary of C. So we know that C is a number, and then D is the binary of that number. And then they printed the integer of D, so they turned the binary number back into an integer. And in the last line, they printed the character of 911, which should be omega. So after we run it, it prints 65, which is the code point of A, capital letter A, and omega is the character which corresponds to the code point 911. So since you found the variable D, we could also print it to check to see what it does. So we could do print D, and it will give us the binary number of the code point of A. So it finds the binary of 65. And let's try running that. So the binary of 65 is the first number over there. And that way we could confirm the variable D. And then after, since we don't need it, we could just turn it into a comment, and then it won't be there anymore. But it's a good idea to check on it, like the stuff in the middle that you don't use, to see if something goes wrong, then which part did it go wrong.